In this video, we'll talk about how we integrate SQL with Python. Specifically, how do we do things like represent the sorts of data types that are in SQL in our Python types. Okay. This is primarily for both talking about how to use the SQLite 3 built-in module that's in Python, as well as to get you guys ready to start on Project 2, which is about implementing a SQLite database. Okay, so what's the big thing to know with regard to Project 2 is that basically Project 2 is implement the SQLite module in Python identically. It has to be character for character the same. So when I say here is a execute command, you should be able to either use your software that you've written for this class or the SQLite module. They should behave the exact same way. And basically, almost all of the rest of the videos this week are suggestions on how you might go about solving that problem. How do you go about actually implementing a SQLite database? But once again, those are all suggestions. The important thing is that your program behaves appropriately. All right, so let's talk first off about the data types between SQL and Python. So we've talked about a number of data types in SQLite, like null, integer, real, text, and blob. How do those correspond to Python types? Well, there's a pretty clear one-to-one relationship. So when you need to represent a null value, Python has this nice type called none that you can use in its place. How do you represent integers in SQLite? Well, you can use the int type. Or how do you represent real values? You can use the float type. How do you represent text? You can use the string type. How do you represent blob? You can use the bytes type. But in reality, we won't be doing anything with blob or bytes. You can ignore that row in this table. Another important thing to talk about right away is type checking. What does that mean? Well, in your schema, for the most part, you specify what type is allowed for each column. You say the grade column is real, or the name column is text. And if you try to insert a value that's not the appropriate type, that statement should fail. It should give you some sort of error back. However, one nice thing about SQLite is that it doesn't actually mind mismatched types. If you say this column should be a text and you insert an integer, for the most part, SQLite will be okay with that. But really, for the purpose of this class, it doesn't really matter. All of the SQLite will be asking your code to do will be correct types, so you don't have to worry about checking for these sorts of mismatches. And what's an example of a mismatch like this? Well, let's say I create a really simple table that has just one column, which is of type text. If I insert a value of 5 into this column, that's a type mismatch. But once again, this sort of code we won't be having in this class, so you won't have to worry about the sorts of type checking. If you care about type checking, you should take my CSE480 Translation of Programming Languages class, because we talk a whole bunch about type checking there. All right, the next thing we should talk about is how do you represent the different parts of your database? Well, the most atomic part of the database is that of a row. So let's say we have this insert into the table named X values, and we have a 1 and a 1.0, and then a string, and then a null. How would we store this information? How do we store this row in Python? Well, the easiest way to do it is to store it as a tuple, which is kind of a type of list that's unchained. You can even store it as a list as well if you'd like. And so what a tuple is parentheses and things separated by commas. It looks a lot like a list just using parentheses. So I have a 1, which denotes to the 1, the 1.0, which denotes to the 1.0. Now note that it says I'm a string, and here I have it in double quotes. It could be single quotes as well, but the important thing is the string that we're storing in Python, note that it only has a single quotation mark. So I'm actually escaping that single quote in my storage so that I only actually have to store the nice version of the string, the unescaped version of the string. And then that null becomes a none. So we're turning kind of one big string that insert into X values, that's one big string, we're converting to this tuple of nice Python types. One thing to be very aware of, and this is an easy mistake to make, is that if a row has only a single value, like in our previous example, and you want to store it, you should also store it as a tuple, okay? Or a list if you prefer a list. So if I'm saying insert into X values, parentheses, and now just one thing, this one string, you need to make sure that you remember that the way that you would store a tuple is parentheses, the thing, comma, close parentheses, and not forgetting the comma. Because if you forget the comma, you don't actually have a tuple here, you just have parentheses around a string. So if you're uncomfortable with how to do singleton tuples, you might want to look that up again. All right, so that's how you represent rows as tuples. At least that's how I recommend doing so. The other thing we need to talk about is how do you talk about the next bigger structure? How do you represent a table? So once again, this is just a suggestion, but the way that my solution solves the problem is that it breaks up a table into actually two parts. One part is the schema, so the table's name and the column names and the types of those columns. And then a separate part of the table is the actual data, the instance, the rows themselves. And the important thing to note is rows aren't necessarily unique. I can add the same row to the table multiple times. Those are different rows. And the other thing to be aware of is that row order doesn't actually matter. Once again, we said that the way SQLite works is that all that it cares about is that the rows were added, not the order in which they were added. The other thing that's important to be able to do is you need to be able to iterate over the rows to get their content. So once you add rows in there, you need to have some way to get them back. All right. Another important thing that a table needs to be able to support is the ability to add and remove rows easily. So I've only taught you how to add rows to the table, but in later videos this week, we'll talk about how to change rows as well as how to remove rows from a table. So first multiple choice question, what sort of data structure should hold the rows of a table? Should it be a set, a list, a bag, sometimes known as a multi-set, or a tuple? So a number of these could work, but some of them can't. So for instance, a set doesn't work really well because a set cannot hold multiple copies of the same item. A set only has unique values. So a set's kind of right out because you're allowed to have multiple rows that are the same. Will a list work? A list actually is probably the best solution here. A list, you can just keep appending to the list as you have new rows. You can remove rows from the list and so forth. Could you use a bag or a multi-set? That actually would also work because a bag is like a set, but you can have duplicates. It's an unordered list in a way. A bag is probably the best option here. However, it's a little bit harder to work with, and I imagine a lot of you are a lot more comfortable with lists than you are with multi-sets, so I'd recommend doing a list, and that's what I do in my solution. You could also use a tuple to represent the data type that will hold all of these rows. The problem is that a tuple isn't modifiable, and so every time you need to make any sort of change to your table, you would have to basically make an entirely new table and copy across all the old values. So in reality, the best option here is probably the list. If you want to be super sophisticated, a multi-set. All right, so we talked about rows, we talked about tables. The next higher structure is talking about the actual database itself. So a database can contain 0 or more tables. And the important thing to note about database is that you need to be able to find tables by their name. We have a table named grades in a particular database. We need to be able to find it by name, so we can say things like insert into grades or select from grades and so forth. So the important thing is you need a way to access a given table, which we talked about in the past, which is probably some sort of list and schema, and you need to have some way to map a table's name to that data. All right, how do you go about doing that? I'd recommend a dictionary, because a dictionary is a really good way to go from a name, a key, to a value, a table instance. Now, how do we work with the database in Python? Well, I'm going to be talking about this again in the next few videos, but the way that it's going to work is very similar to how you interact with the SQLite 3 module in Python. So if you want to see how the SQLite 3 module in Python works, it'll be linked to from the description here. And the way that it works is like so. What you do is you're going to import project. The name of your project2's file is project.py, so I'm importing that project and importing that module. And then the next line is I'm saying, I want to say project.connect a particular file name. And this is going to give me back an object that I'm going to be able to work with. And I'm just calling it CNN for connection. And I'm going to say, hey, connection.execute. And then I pass in a string, which is a SQL statement. All right, so I create a table named myTable, which has a single column. And then I say, hey, connection.execute this next SQL statement. Insert into the value Josh into this table. Okay. And then the next row, I say rows equals connection.execute select star. So what execute actually does is it always returns something, by default, it returns none. However, when I do a select statement, it should return a list of rows. And so then the last couple lines is just going through each of those rows and printing them out. All right, so let's break down these parts to what you actually need to do in order, once again, to solve project 2. So the connect thing in the project module takes a file name and returns a connection object. And now for right now, the file name won't actually be used, but in later projects it may be. The file name is really where the database should be being stored in. But for right now, you can ignore whatever file name I give it. However, the thing that's returned needs to be returned because this is actually how you access the database. You use it to pass queries and to get results from the database using the execute method. So let's go and talk about that. So the execute method on the connection object takes a string, which is a SQL query, and returns an iterable object, which is really, for the most part, just a list, or none, depending on if the query returns rows from the database. So one way that you can implement this is you can do the query, and then if it's not a select query, you could just return none. Otherwise, you return a list of rows, which, if you're doing it according to my solution, each row is a tuple. And you're allowed to return an empty list if no rows exist. Like if I call select star on a table that doesn't have anything in it, it would return an empty list. So how do you go about writing the execute method? Well, we promised that the string provided the execute method is always a legal SQL statement. And for project 2, there's only a few different statements you need to bother with. The create table statement, the insert into statement, and the select statement. Okay. So the one thing to be aware of is that, like SQL, you're allowed to have white space before, after, and within queries. What is white space? Space characters, new lines, tabs, read lines. And you're allowed to have those before the statement, after the statement, as well as in the statement. So I could say create tab, table, space, students. And that means the same thing as just create space, table, space, students.